In this short video, we will demonstrate how to use the Theorem Prover plugin for the Compass tool platform. The plugin uses the Isabelle Theorem Prover, which we have set up previously. Instructions for doing this are in the Theorem Prover support user manual. This video will show how to create CML model-specific Isabelle theorems necessary for theorem proving in CML, using the Isabelle perspective in the Compass tools, and how to prove some simple theorems. We begin by using the Dwarf signal model in the normal CML perspective of the Compass tools, as we can see here. In the CML Explorer pane, we right-click on the CML model, select the CML-thy option, and then generate Theorem Prover thy. This does a few things. Firstly, the perspective has changed to the Isabelle perspective, which we will look at in more detail shortly. Secondly, some new files have been created and opened. Again, we will look at those shortly. Finally, we'll see some new folders have been added to the Dwarf Signal project, which we'll have a look at now. If we look in the Project Explorer, a generated folder has been created containing an Isabelle folder, which contains all the generated files in individually timestamped folders. In the most recent folder, we have 3 files now. The first, in the model folder, is a backup of our Dwarf model, which ensures that we have a CML model directly corresponding to our next file, the dwarf.thy file. Looking at this, we can see that there are various parts with a grey background, which indicate that the Isabelle tool has not been processed this yet. And there are also various parts of Isabelle markup. For example, the \parallel command, which again will be changed into Isabelle syntax when Isabelle tool is running. Finally, we have a user editable file, dwarf_user.thy. This imports the UTP CML theories, as well as this new dwarf.thy file that we've created previously, and it allows us to do user-created model-based theorems and lemmas. Next, we start a previously defined Isabelle configuration. To do this, we click on the play with the Isabelle logo, and then Isabelle-CML, which we've set up previously. As the tool starts, we can see different parts of the Isabelle perspective being populated. The Simple View pane in the bottom right provides a quick method for entering Isabelle symbols. Above that, in the Theory Outline pane, this provides an outline of the selected theory file. The bottom left shows the Prover Progress pane, showing status bars for the different theory files. Here we see both files have been completed. Finally, below this, in the Prover Output pane, we see any warnings or proof output from Isabelle. Having a look at those 2 theory files again, we now see that there's been some various syntax highlighting, and in the dwarf.thy file, the various parts of Isabelle syntax, so for example these parallel bars, have been entered. To start proving, I'll go back to the user editable file and paste in some simple theorems. Here we have a few lemmas, 2 of which are simple logical statements. And we start by demonstrating that the CML proof tactics can discharge these simple logical theorems. By doing this, we change this oops keyword, which says that we don't want Isabelle to process the various lemmas, with the CML automatic proof tactic. This is used by calling the by keyword and then CML auto tac. Isabelle will work through that, and now we see any red warnings have disappeared and followed by various yellow warnings, which we don't need to worry about so much. We can go ahead and do this for our second goal. Again, once Isabelle works through it, it's discharged absolutely fine. Next we can repeat these for the simple theorems of our model. These ensure that the example states, for example, of a Dwarf signal satisfies some of these safety properties that we've created in the Dwarf model itself. Again, we can use our CML auto-tack to overwrite the oops keyword and discharge each of these lemmas in turn.